Welcome to Study Loop.
In the first part of this problem, we are going to calculate the energy stored in the magnetic field and we are going to compare the results. So first we need to calculate UL. Let's write the equation for this UL as UL is equals to 1 divided by 2 capital Li square. We call it equation number 1. Now the current through the inductor is written as I is equals to E divided by R into 1 minus e raised power minus t divided by tau. Now at t is equals to tau, this equation can be written as I is equals to E divided by R into 1 minus e raised power minus 1. Now by inserting values for this E and R, we can write this equation as I is equals to 6.00 volt divided by 8.00 omega into 1 minus e raised power minus 1. So this will give us the value for this I is equals to 0.474 ampere. Now by inserting values into this into the equation number 1, we can write equation number 1 as UL is equals to 1 divided by 2 into L, which is equals to 2.50 Henry into 0.474 ampere whole square. So this will give us the value for this UL as UL is equals to 0.281 joule. Now let's take the equation from the exercise 30.27 where the power PL is written as PL is equals to dUL divided by dt, and this can be further written as Li di divided by dt. We call it equation number 2. Now let's take the first time derivative of the current as di divided by dt is equals to d divided by dt into square brackets open e divided by r into 1 minus e raised power minus t divided by tau. So square brackets close. So this derivative gives us as di divided by dt is equals to e divided by L into e raised power minus t divided by tau. Here we have used the equation for the time constant tau as tau is equals to L divided by R. Now by inserting the value of I and di divided by dt into equation number 2, we can write equation number 2 as PL is equals to L into e divided by R into 1 minus e raised power minus t divided by tau. Brackets close into di divided by dt, which is equals to e divided by L into e raised power minus t divided by tau, brackets close. Now this can be simplified as PL is equals to e square divided by R into e raised power minus t divided by tau minus e raised power minus 2t divided by tau. Now we can write the energy corresponding to this power as UL, and this is written as integration of PL dt, and the limits of integration start from 0 to tau. Now let's insert this value of PL into this equation. So this will be UL is equals to integration of 0 to tau, and here we can write e square divided by R into e raised power minus t divided by tau minus e raised power minus 2t divided by tau, square brackets close, and here will be dt. Now at t equals to tau. This integration can be written as UL is equals to 1 divided by 2 into E divided by R whole square, and here we have L, and then we have square brackets open 1 minus 2 e raised to power minus 1 plus e raised to power minus 2. So by inserting values into this equation, we can write UL is equals to 1 divided by 2 into 6.00 volt divided by 8.00 omega whole square into 2.50 Henry into 0.3996. So this will give us the value for this UL as UL is equals to 0.281 joule. So this validates the result we obtained in the first case. In the second part of this problem, we are going to calculate the power supplied by the battery, that is UB. Sorry, the energy supplied by the battery, that is UB. Now, in order to calculate this energy, let's write the equation for the power supplied by the battery as PB is equals to E multiplied by I. So this can be further written as E into E divided by R into 1 minus e raised to power minus t divided by tau. So this is equals to E square divided by R into 1 minus e raised to power minus t divided by tau. Now the energy corresponding to this power is written as UB, which is equals to integration of PB dt. So by inserting value of PB into this equation, we can write integration of E square divided by R into 1 minus e raised to power minus t divided by tau, and here we can write dt. Now at t is equals to tau, this integration will be equals to E square divided by R into tau e raised to power minus 1. So this can be further written as E square divided by R, and here we can write L divided by R, and then here we have e raised to power minus 1. So this can be simplified as UB is equals to E divided by R whole square, and here we have L e raised to power minus 1. Now by inserting values into this equation, we can write UB is equals to 6.00 volt divided by 8.00 omega whole square, and here we have L, which is equals to 2.50 Henry e raised to power minus 1. So this will give us the value for this UB as UB is equals to 0.517 joule. In part C of this problem, we are going to calculate the energy dissipated in the resistance of the inductor, that is UR. In order to calculate this UR, we write the corresponding power as PR is equals to I square R, and this can be written as E divided by R whole square into 1 minus e raised to power minus t divided by tau, and here we have R. So this can be simplified as E square divided by R into 1 minus e raised to power 2 e raised to power minus t divided by tau plus e raised power minus 2t divided by tau. Now the corresponding energy can be written as UR is equals to integration of PR dt. Now by inserting the value of PR into this integration, and then after solving this integration at t is equals to tau, we can write the result for UR as UR is equals to E divided by R whole square. Here we have L divided by 2, and here we can write minus 1 plus 4 e raised power minus 1 and minus e raised power minus 2. Now let's write the values into this equation. So it will be UR, it is equals to 6.00 volt divided by 8.00 omega whole square, and here we have 2.50 Henry divided by 2 into 0.3362. So this will give us the value for this UR as UR is equals to 0.236 joule. So this is the answer to the part C of this problem. In part A of this problem, we are going to compare the results. So we claim that the energy supplied should be equals to energy consumed. So this is equals to UL is equals to UB is equals to UL plus UR. So by inserting the values into this equation, we can write 0.517 joule is equals to 0.281 joule plus 0.236 joule. So this will give us 0.517 joule is equals to 0.517 joule. So this validates the law of conservation of energy. Therefore we can say that the calculations are true. End of the question. Thank you.